A flying air defense battery, a modern champion in altitude and speed, a fighter, some capabilities of which at the time of its creation were simply shocking. We are going to get acquainted with the history, design, and capabilities of the aircraft that, half a century after its first flight, remains an extremely dangerous predator. Hello aviators, Sky here, and today I present to you the MiG-31. In 1964, the E-155 prototype took to the skies, the brainchild of the Mikoyan and Gurevich Design Bureau, which a few years later became one of the most formidable combat aircraft of the Cold War, the MiG-25. This interceptor was considered a miracle of engineering thought, possessing amazing flight performance, 3,000 km per hour speed, 23 to 25 km altitude. It not only broke many world records, but also reshaped the strategy of aerial warfare. And the irony is that the change in strategy for which the MiG-25 was the cause accelerated its own moral obsolescence. The concept of high altitude and high-speed penetration, when bombers and reconnaissance aircraft evaded air defense due to the speed of Mach 3 and the altitude of flights of 25 kilometers, no longer worked. And in its place came the concept of low-level penetration, when aircraft and cruise missiles flew so low that large ground radars simply could not see them. Interceptors assumed close cooperation with ground air defense forces, and if they did not see anything, then problems also arose in the air. The MiGs clearly lacked autonomy. The problems did not end there. The MiG-25 was a specialized supersonic high-altitude interceptor and could not operate effectively at a wide range of altitudes and speeds, and the pilot's workload during missions was too high. As strange as it may sound, such monsters as the XB-70 were an easier target for it than some small planes skimming over treetops. The disadvantage was also felt in the flight range. This is why, even with the advent of the new interceptor, no one seemed to write off the old Tu-128. It was in many ways worse, but it could fly far and for a long time. In principle, all of the above cannot be called the result of mistakes. The MiG Design Bureau knew about all these factors from the very beginning, but they went for it since otherwise it was simply impossible to create an interceptor with the required parameters in a short time. And even at the stage of implementation of the E-155 project, the designers thought about how they would solve these problems in the future. The official start of the program, which received the E-155 MP index, was given in 1968. The military requirements assumed both the preservation of the top parameters of the MiG-25 and a serious expansion of functionality. Greater range and autonomy, the ability to operate at all altitudes, as well as the ability to attack almost any target, even ground ones. The fourth generation of fighters was looming on the horizon, and such inciting terms as multi-purpose had already begun to appear. There were many concepts, from modifications of the basic aircraft to very exotic design. Ogival wings, variable sweep wings, everyone loved them at the time. Twin fin tail, single fin tail, no tail. Engineers were leaning towards a single fin two-seater with a variable sweep wing, a kind of super MiG-23. But the original plan was not realized. Research and testing experience of the MiG-23 showed that the design with variable sweep was too complex and heavy, which would inevitably affect the flight performance. The military requirements were also adjusted. Their zeal cooled slightly, and the desire to create a universal multi-purpose platform was replaced by a more pragmatic version of an interceptor that was more universal than the MiG-25, but still high speed. It still had fighter capabilities, but it no longer claimed to be a bomber. The newest Su-24 was now responsible for that. As a result, they decided to make a new aircraft, but still use the MiG-25 as a base. All these arguments and changes took quite a long time. The first prototype took off only in 1975, and it was an aircraft with the MiG-25 MP index. Soon more prototypes took off, which were almost MiG-31, but without some of the onboard equipment, which was not yet ready. The situation was complicated. On the one hand, the MiG-25 was a very modern aircraft, so there was no need to race against time. On the other hand, the project was starting to drag on, which irritated the customers. This irritation grew even more in 1976 after the basic interceptor MiG-25P was hijacked and taken to Japan, and the disclosure of its secrets required urgent measures. Then the MiG-25PD was created, which was perceived as a forced decision, since the MiG-25P was no longer suitable and the MiG-31 was not yet ready. But even with all the resources available, testing and improvements were difficult and required several years of work. Finally, in 1981, the entire system was accepted into service. The E-155MP became the MiG-31. Let's take a closer look at it. So, we are in Patriot Park Museum, located not far from Moscow and filled with a bunch of cool exhibits, one of which is our hero. The general layout of the MiG-31 is more or less the same as the MiG-25, but with adjustments that make it seem like the 31st is somewhat smaller than the 25th. This is an illusion. The length is 21.6 meters, wingspan is 13.5 meters. Very close to Daddy, while within the overall dimensions, some elements have become larger, with corresponding changes in weight. The experience of the MiG-25 service, the development of technologies, and somewhat more gentle operation allowed to change the selection of alloys of which the new aircraft was made. While the 25th is 80% steel, the 31st has reduced this figure to half. Mainly the central part of the fuselage, again welded, while the share of aluminum has grown to 33% and titanium to 16%. It would seem that an aircraft made of lighter materials should be lighter, but it is not so. Fully equipped, the MiG-31 weighs 46 tons. It is 6 times heavier than the MiG-25 and 3 tons heavier than the huge Tu-128. The Su-27, which is really not a small or light plane at all, is just a baby next to this thing. The landing gear is appropriate. The main gear received bogies with 2 wheels, located not next to each other but with an indent. This made it possible to strengthen the legs, reduce the load on the ground, and maintain relative compactness. They are retracted forward and, an interesting solution, the front doors of the fairing also work as aerodynamic brakes. The nose gear is also 2-wheeled. Unlike the MiG-25 gear, it retracts backwards rather than forwards. Apparently, the very dense nose filling left no room for a niche, and it had to migrate. And the engineers had to turn this thing into a maneuverable fighter-interceptor. Not a trivial task. In terms of aerodynamics and control, the new machine is different from the old one, although at first glance everything's the same. The plane has a new wing, its internal layout has changed, and there are leading-edge extensions on the outside. The fuselage also began to create part of the lift. The high-lift devices were improved, the flaps and ailerons became larger, and in front, slats appeared. The tail unit in general has not changed much. A pair of all-moving stabilizers, a pair of large fins slightly inclined to the sides, and a pair of under-fuselage fins below. All these solutions yielded results. The MiG-31 learned to fly normally not only at supersonic, but also at medium speeds with more or less decent maneuvering. Without flattery, it is still an anvil with wings, and it is very far from maneuverability of the Su-27. But compared to the MiG-25, it is a real dancer. Landing speed is about 280 km per hour. Takeoff run is 12 to 1300 meters, landing run 8 to 900 meters with the use of brake parachutes. Still quite a lot. Better aerodynamics were compensated by greater weight. At least there was no need to redesign the airfields. If the MiG-25 could work there, then the 31st can too. And now in more detail about why the MiG-31 is so heavy. The first reason is the power plant. The main secret of the MiG-25 speed was its engine. The R-15B300 was a mad dragon that could easily fly at supersonic speeds. But everything has a price. This dragon had a short service life, drank a lot of fuel, and although it flew well at Mach 3, it was not very effective at subsonic speeds. It had to be replaced. At first, the RD-36 was considered a promising option, different versions of which were installed on the Yak-38, Tu-144 and T-4, the famous titanium Sukhoi Sotka. But it didn't work out. It was very complex and expensive, and hopes for reducing cost due to mass production melted away when the Tu-144 and T-4 projects started to sink. The alternative turned out to be unexpected, the D-30. This turbofan engine was new, efficient, economical for that time, and mass-produced. It was installed on many aircraft, from the Tu-134 to the Il-76, which promised certain economical and operational bonuses. Here I must emphasize, don't think that they simply took the engine from a subsonic airliner and installed it on the supersonic interceptor. Apparently, this impression arose among those who first heard this idea, since at first, many perceived it, to put it mildly, skeptically. But engine designers proposed a serious modification, and thanks to additional research and immeasurable persistence, it was proven that this option was quite operational. Thus, the D-30 F6 was born. There were many changes. The temperature in the combustion chamber was increased, several stages were added, and an afterburner was installed. Many materials were replaced with more durable and heat-resistant ones. Adjustable blades, additional bypass duct, complex cooling system, and duplicated control appeared. Side effect, while the R-15 was big, the D-30 was even bigger, which forced the fuselage to be enlarged, especially in length. The adjustable nozzles were separated. On the MiG-25 they crossed. The design of the air intakes is in general similar to the MiG-25. On the sides of the fuselage are two large wedges with adjustable flaps below. The channels have become more complex. They received several dynamic panels and diversion of the boundary layer. This entire system provides an optimal airflow to the engines, adapting to different altitudes and speeds. The performance turned out to be good. The thrust increased to 93 kN without afterburner and 152 kN with afterburner, half as much as the MiG-25. The engines became multi-mode, and what is no less important, the turbofan design boosted fuel efficiency. Compared to the R-15B-300, their consumption was 21% less with afterburner and 42% less without afterburner. The priority here, of course, is not in economy and ecology. The new engines promised a solution to one of the main shortcomings of all interceptors: limited range. In terms of the fuel system layout, the MiG-31 is a successor to the MiG-25. Most of the internal volumes are sealed tanks for the T6 fuel with a high ignition temperature, and as it is consumed, filling the empty volumes with inert nitrogen so that it burns only where it is needed. And there are many of those tanks, 7 in the fuselage, 4 in the wing, and 2 in the fins. The fuel reserve is about 16.35 tons, plus another 4 tons in a pair of external fuel tanks. The combination of a larger fuel reserve and economical engines provided the coveted leap in range. At subsonic speed, it flew at a distance of up to 3,000 kilometers with 4 missiles and 2 external tanks. At supersonic speed of Mach 2.35 with 4 missiles, approximately 1,400 kilometers. The MiG-31 acquired the range parameters of the Tu-128, and Grandpa was finally able to peacefully retire. But all these improvements had a cost. The ceiling of the aircraft varied from 20 to 23 kilometers depending on the load, which was slightly less than that of the MiG-25. Flight speeds also suffered a bit. Cruising supersonic varied between Mach 2.35 and 2.55, 25 to 2700 km per hour. Maximum Mach 2.8, the canonical 3000 km per hour. But no more. Turbofan engines do not like extreme conditions, and while the 25th exceeding the speed led to overheating of some elements and the pilots sometimes allowed themselves to race, here such stunts can kill the power plant, and this is already dangerous. This is why the MiG-25 remained a proud owner of many records. On the other hand, this lag is insignificant, and the record holders have long since retired, leaving their successor as the leader. Now only astronauts can fly faster and higher than the pilots of the 31st. One of the most obvious external differences between the 31st and 25th is the two-seater cockpit. The problem of overloading the pilot was solved simply. A navigator-operator responsible for onboard systems and weapons was seated behind him. The canopy is single, but inside it is divided into two cockpits with separate operating segments, similar to the SR-71. Visibility here, of course, is better, but there are a lot of closed metal parts. The glazing is made of heat-resistant plexiglass. Later versions improved visibility. Above the front cockpit there is a small growth with a mirror, giving the pilot a rear view. And above the rear cockpit there is a periscope, a mirror that extends, for example, during takeoffs and landing, and gives the navigator a view forward. A new seat was made specifically for the new MiG. The K-36DM greatly extended the operating ranges. Speeds at the moment of ejection from 0 to 1400 km per hour. Altitude from 0 to 30 km. Overload was reduced from 20 to approximately 15 G, a great gift to the spinal vertebrae. Over time, the K-36 became the basis of a whole family, which found a place in the cockpits of most Soviet and Russian fourth-generation fighters. Let's move on to the onboard equipment. This little world, hidden from prying eyes, became no less of a challenge for the MiG's creators than the airframe or engines. The most stringent requirements were for the radar. It had to see targets at a wide range of altitudes and speeds, from a light civil plane above a cornfield to a reconnaissance aircraft in the stratosphere. In addition, the requirement for autonomy meant independence from ground systems, meaning that the MiG's radar had to have capabilities almost like those of its ground-based counterparts. Take this and shove it under the fairing of an interceptor. Good luck. At first, such conditions could be shocking. With the technologies of that time, it was hardly possible to make a classic radar for an interceptor with the necessary performance. In search of a solution to this problem, engineers pulled quite a stunt. An electronically scanned array radar is a design that has not one large canvas, but a network of many blocks assembled into a kind of honeycomb panel. The MiG-31 was equipped with a passive phased array radar called Zaslon, or barrier. And Zaslon was good. It scanned not by mechanically rotating the panel, but by manipulating the beam, thanks to which it could do it much faster and more efficiently. It tracked targets at a distance of up to 200 kilometers and engaged them at a distance of 120 kilometers. Meanwhile, it could track 10 targets at once and engage 4. In these parameters, it was inferior perhaps only to the AN/AWG-9 radar from the F-14 Tomcat, which at that time was considered the apogee of aviation electronics technology. Moreover, the MiG-31 not only became the first fighter equipped with a phased array radar, but also remained almost its exclusive carrier for many years. The next radar of this type was the JAPG-1 on the Mitsubishi F-2 fighter, which was accepted into service only in the year 2000. But there is always a but. Such radars are complex, expensive and bulky, so before they had only been used on ground installations and ships. Squeezing something like that into a fighter is not an easy task. Zaslon was one of the reasons for such a long process of creating the aircraft. And it was implemented precisely on the MiG-31, a large and heavy aircraft with, in some places, specific functionality. It simply wasn't justified to expand this practice to all. Therefore, other fourth-generation fighters, including Soviet ones, were equipped with conventional radars. Now, when the technology has reached the required condition, most aircraft are being equipped with phased array radars, but active, not passive. So there is no need to bring the drama to the level of the MiG-31 has a radar of 5th generation fighters. Zaslon on the MiG and Belka on the Su-57 are very different devices. However, I would like to emphasize that this criticism concerns not so much the radar itself, as its sometimes overly colorful descriptions. Zaslon was undoubtedly very cool for its time, but as strange as it may sound, even it does not seem like such a breakthrough compared to what is hidden behind it. The aircraft is literally stuffed with equipment. In conjunction with the radar, there's the infrared search and track system, which can scan space in the infrared spectrum and guide missiles with infrared homing. There are several navigation systems, including a global one, which connected to the Marshroot navigation network. Along with the American Omega, it can be considered the forerunner of modern satellite navigation systems, such as GPS and GLONASS. The automation is incredibly developed. The aircraft does most of the work itself, which led to a side effect. While the MiG-25 pilots were overloaded, the MiG-31 crews sometimes get bored. The communication system allows the aircraft to interact with each other and with allies. The MiGs are able to distribute roles among themselves, so that, for example, one fires missiles, the second guides the missiles to targets, and the third acts as a flying control system, receiving data from all the group's radars at once and controlling the actions of other aircraft. And all this is automated and independent of ground infrastructure. Yes, it took years to implement many systems. You shouldn't think that everything appeared at once. But this is practically a network-centric warfare on a local scale. 4 MiGs are able to control an area stretching from 8 to 900 kilometers, almost the length of the east coast of Great Britain. With the introduction of such functionality, the issue of autonomy was closed. Many third-generation fighters began to seem frankly primitive, and modern fighters did not learn such tricks right away. The final chord in the performance and functionality is what makes it in fact a combat aircraft, the armament. Considering the range of potential actions of a fighter-interceptor, the armament has become much more diverse. And since the number of suspension points on the wing was limited, the engineers approached the issue creatively. The main caliber of the early MiG-31s was the R-33 air-to-air missile, the creation of which was undertaken in parallel with the development of the E-155 MP program since the late 1960s. The layout assumed the placement of 4 missiles, 490 kilograms each, under the fuselage with a slight immersion into the hull. During the launch, special catapults pushed the missiles away from the aircraft, after which its engine starts. This allowed to reduce the resistance and loads in flight, plus prevented the engine exhaust from going into the air intakes. But it imposed restrictions on the dimensions. The R-33 is slightly thicker but shorter than its colleagues. The empennage is compressed and the upper rudders are folding. The missile was capable of hitting targets at a distance of up to 120 kilometers on a head-on course, flying at altitudes from 30 meters to 28 kilometers, at speeds of up to Mach 3.5, 3,700 kilometers per hour. That is, practically any target, with the exception of perhaps ballistic missiles. When describing the missile's appearance, an attentive viewer may have a seditious thought. Wait, that's a Phoenix. Yes, the main calibers of the MiG-31 and F-14 are similar in appearance, but their filling is different. The MiG missiles received semi-active homing and were guided to the target by the aircraft's radar, while the F-14 arrows have active homing and could aim independently, unloading the carrier's radar. The AIM-54 is more technologically advanced, but because of this, it turned out to be very expensive. So expensive that the US Navy, the very ones that have 11 nuclear aircraft carriers in service, tried to save money by not using it unnecessarily. The R-33 is also a very expensive thing, but it was easier to work with. The remaining missiles are more classic and are suspended on pylons under the wing. The R-40 medium-range and R-60 short-range missiles were put here. And the position of brute force was taken by the GSH-6-23, a 6-barreled 23mm cannon installed under the fairing in the lower part of the fuselage on the right, hidden by a flap when inactive. There was a lot of controversy around the cannon, since many considered it useless on a high-speed interceptor. In fact, the 25th did not have one. But the MiG-31 is also a fighter, and any school kid knows that a fighter without a huge cannon is not a fighter. Production of the aircraft was established in 1976 at the facilities of the Gorky Aircraft Plant, today's Sokol, where the MiG-25 was also being made. The common base simplified the work, although the new aircraft turned out to be significantly more expensive. Immediately after their adoption into service in 1981, they began to be actively transferred to the Air Force. In regular service, they, along with the MiG-25, patrolled the air borders of the USSR and also accompanied reconnaissance aircraft flying on the other side of the border, such as the RC-135 and of course the stars of high-speed espionage, the SR-71. Everyone is interested in how they were chasing each other, and their chases had nuances. In general, already with the advent of the MiG-25, reconnaissance aircraft lost the ability to fly over the territory of the USSR, but the old interceptors were tied to the ground systems, the density of which was unevenly distributed across the country, and there were still areas where it was possible to slip through for a short time. The MiG-31 closed this window. While earlier, knowing the location of air defense systems, it was possible to find loopholes, now these systems flew where and how they wanted, leaving no gaps. The Blackbird was still faster, but the new radars and interceptor missiles made this advantage insignificant. Vis-a-vis noticed the new neighbors immediately. At first, the MiG-31 had the NATO index Super Foxbat, since US intelligence believed that it was an updated MiG-25. But after receiving more detailed data, they changed the index and gave it a new name, Foxhound. But the years passed. Over time, not only the tactics of strategic aviation changed, but also its role in the nuclear triad. While in the 1960s the main carriers of nuclear weapons were planes, by the 1980s the priority had shifted towards ballistic missiles. The MiGs were losing their purely defensive role, and now had to be able to operate outside the country, escorting bombers and covering the fleet. This required a great range, which was ensured by the aerial refueling. Fortunately, by that time, the new Il-78 tanker had arrived, created on the basis of the Il-76. Autonomy was also expanded by upgrading the onboard equipment. Moreover, the zeal to redo everything again was caused not only by the thirst for progress, but also, yes, by another leak of secret information. No one hijacked the MiG-31, but within the walls of the institute that created this equipment worked a certain Adolf Tolkachev, who turned out to be a CIA agent. The result of modernization were the MiG-31DZ and MiG-31B, some components of which were eventually implemented on the already delivered aircraft. A milestone in the development of the program was the MiG-31M project, which involved a more radical modernization with changes to the systems, design, and armament. But the seriously modified aircraft required additional work, the period of which coincided with the collapse of the USSR. Having lost support, aircraft manufacturers were unable to bring the M version to production, and the production of the MiG-31 itself began to shrink. New orders were not coming in. Of course, there were many projects for export modifications, especially since the experience of exporting the MiG-25 was not bad. But the 31st was more complex and expensive, it had a lot of secret elements, and it began to be delivered rather late. In the 1990s, potential contracts were considered, but customers were leaning towards the more versatile Su-27 and Su-30. As a result, by 1994, production of the MiG-31 was finished. A total of 519 aircraft were built. The game of cat and mouse continued. In the 1950s, the main method of strategic penetration by aviation was considered to be high altitude. In the 1960s, surface-to-air missiles closed this window, and a new way appeared, high altitude and high speed, and this window was closed by the MiG-25 interceptors. The answer to this in the 1970s was the emergence of low-level penetration, and this window was closed by the MiG-31. And so, in the 1980s, another solution was found. Since jumping over and rushing in doesn't work, you can try to slip through unseen. Describing the radar range parameters, I omitted a nuance, the dependence on the radar cross-section of the target, its luminosity. When you see a statement that a radar sees at a certain distance, usually we are talking about the limit with the brightest in this regard targets, like old strategic bombers. In the case of fighters or cruise missiles hugging the ground, this indicator is reduced. As a result, this luminosity began to be reduced intentionally, adapting the materials and designs of aircraft. In a sense, we can say that the MiG-31 set a task, the answer to which was the stealth technology. A peculiar fuss about this arose at the Paris Air Show in 1991, where the MiG-31 and F-117 were presented simultaneously for the first time. The clash between Zaslon and Nighthawk became the beginning of the now classic confrontation between a radar and a stealth aircraft. Russia was in no hurry to respond to the new challenge. Both politically, the Cold War had ended and the threat did not seem serious, and economically, there was no money not just for a new aircraft, even the existing fleet was difficult to maintain. As a result, skepticism began to form in relation to the MiGs. The debate arose with renewed vigor. Is it just an interceptor or a fighter-interceptor? And what generation is it? Already the fourth or still the third? And what difference does it make? Stealth aircraft have reshaped the concept of aerial warfare, and while the MiG could stand against the old machines, the prospects of meeting new bombers, cruise missiles and fifth-generation fighters, almost all stealth, were very vague. I'll admit, it would be interesting to see the results of, for example, a training fight between the MiG-31 and the Su-57, but let's be honest, no one will show us such a report for a very long time. One way or another, many believe that the 31st was outdated and should be replaced by new aircraft, such as the Su-30 and Su-35. Nevertheless, the Sukhois, for all their coolness, could not completely replace the MiGs, and if the interceptors were retired, a hole would appear in the air defense umbrella. In the late 1990s, having gathered their strengths, Mikayans decided to upgrade the fleet by modernizing and implementing solutions from the closed M project. The design was not changed, but the filling was transferred. This is how the MiG-31BM appeared, which has become the current version at this moment. The range parameters, thanks to the improvement of aerial refueling capabilities, were brought to the limit. In 2016, during a transfer of fighters across Russian territory, the aircraft with 3 refuelings spent more than 7 hours in the air, flying in total about 8,000 kilometers. The creation of the Zaslon M radar was a major step. The detection range increased from 200 to, according to various estimates, 320 to 400 kilometers. The number of tracked targets increased to 24, and engaged targets to 8. The combat loads reached 9 tons, and the range of weapons grew even more. The R-37 missile appeared, Mach 6, with an active homing and a range of almost 300 kilometers. Beside it appeared the R-77 medium-range missiles, R-73 and R-74 short-range missiles. Anti-radar and anti-ship missiles such as the Ha-31 and Ha-58 can also be used. In theory, it can also carry aerial bombs, and if they are guided, this may even make sense. But as in the case of the MiG-25, this possibility is rather theoretical. Then this work was done by the Su-24, and now the Su-34. Of course, we cannot ignore the MiG-31 versions that are carriers of special devices. Ever since the MiG-25 project was initiated, ideas have always arisen to hang something large and powerful under the high-altitude, high-speed aircraft. But while on the 25th these were just ideas, on the 31st they were brought to practice. The MiG-31D project dates back to the 1980s and involves modifications to combat targets in space using anti-satellite missiles. The Star Wars arms race was in full swing. In the US at the same time, as part of the ASAT program, they were conducting test launches of anti-satellite missiles from the F-15 fighters. But after the end of the Cold War, all these initiatives stalled. For some time there were civil projects with launches of light rockets from aircraft, but they never came to fruition. It could all be written down in a history book and forgotten, but recently it became known that the project was revived and is now being tested. And of course, the implementation of the long-standing idea to give the MiG-31 the function of a bomber, and the star of the recent times, the MiG-31K. A carrier of the Kinzhal air-to-ground missile, the very one that has caused so much noise. This is already a fully operational system, which I talked about in detail in a separate video. According to open sources, Russia currently has about 140 aircraft in service, mostly the MiG-31BMs, plus a couple dozen MiG-31K jets carrying Kinzhal. Fortunately, the MiG did not have to perform its immediate task of defending against enemy bombers. Unfortunately, it did not have a completely peaceful sky either. The first war in which the MiG-31 took part was the war in Chechnya. There was no one to fight in the air, and the planes created to intercept cruise missiles and bombers were watching to make sure that no light planes appeared there smuggling weapons. The next deployment for the MiG-31 was Syria, where a group of aircraft provided airspace control. And then 2022 happened. What can I say? The designers of the MiG-31, when creating this machine in the 1970s, considered a million scenarios, from the fight against drinking technical alcoholic liquids to a nuclear apocalypse. But this certainly did not occur to them. Nevertheless, the MiG-31, despite its age, is actively being used there along with new machines, precisely because of its special capabilities. It remains to be hoped that we, nevertheless, will not have to find out whether the Slon can see stealth aircraft or not. On this uncertain note, I think we can wrap it up, and wish the MiGs a long and boring service with beautiful target shooting during training exercises. And to you aviation fans, clear sky, fast flights, and soft landings.